Start by a brief description of who you are and what you have done, then we can go to the next.
My name is Dr. Davidson Mwangi. I'm an agronomist. That is a study in agriculture. I have a PhD from America, Iowa State University. And I've been working for more than 35 years as a scientist in different countries, in Africa, African countries, and America also. In 2015, I bought this farm where I'm conducting or carrying on with research that is helping to develop a new seed. My specialization is on green amaranth seed, that's where I am, and also cattle breeding on the seed. I've been working for many years. Especially the advanced stage is the study of the plant from the roots all the way up to the production of producing the seed. You study how the plant develops the seed, how the plant matures, the cells, the tissues, the molecule, like trying to find out all about the plant and utilization of that plant, because after getting the plant, end product is the seed. What do you do with it after getting that? So that is the study that I've done.
Now, as we were talking earlier,
Yes.
you happened to talk about your experiences in various countries, various sections of this country, that is Uganda and the rest.
Yes.
You also talked about you being in America.
Yes.
Maybe you can kindly brief us about your stay in America and across those countries that you talked about.
Yes.
What were you doing in America? What were you doing in those countries?
Yes.
And maybe you can talk of some milestones of
Yes.
your career.
When I was in America, I was studying at Iowa State University about the agriculture. That is my profession, which is agronomy. And then from there, I did a lot of research in America. I was doing research in 5 states. I did research in Wisconsin. I did research in Iowa State, in Colorado, Chicago. I did a lot of research in several of these states. And finally, I came back to Kenya. And when I came back to Kenya, I also spread myself to other countries. I was hired by some American organizations to go and train. This time was to introduce my work to Zimbabwe, that's the country I started with, Uganda, Tanzania, South Africa, South Sudan, and Uganda. And finally, I worked in Uganda for many years, because my last assignment in Uganda, I was working under a Russian company. I was also hired by a Russian company as a research director. So I've been working all the way through to develop the seed of this crop through cultural breeding, that is natural breeding, not GMO. And I developed the seed, and I also multiply the seed for the farmers. So even here, we have the seed for the farmers who contracting. So basically, my work is developing the seed and training. I've been training all the way through. Training the farmer, training institutions. Even sometimes I would lecture in some universities. That's what I've been doing. What you can see here is my work as a scientist. I'm an agronomist, and part of my work is breeding and improving seeds for green amaranths. These amaranth seeds. These are the plants that you can see. These are different varieties, if you look at it. And then after getting this, then we make the products, which you can also see here. This time we were in Mombasa show, and during that time, the current president was the Minister for Agriculture. You can see him with me there. I'm explaining him about this in Mombasa show. And what we do is, this crop is a food crop, because we mill flour, we also pop, and we can also extract oil, very good oil from it. This was crop in Loitoktok. You can see during this time was my partner, Ms. Mzungu. This is the time of thinning. You thin the crop before you can get to this. And this is the way people use it for cooking porridge. You can see people cooking porridge. And you can see people in the field working on it. Like here it's in Uganda. Here is in Zimbabwe, when I was working in Zimbabwe. And here is in Tanzania, when I was working in Tanzania. We were giving some lecture and then food. So basically what we have here is the work that I've been doing for many years, over 30 years. And then from there we improve and we get the seed from this crop. So our work mainly is to develop the seed for the farmer and to train the farmer. And this.
Now, as you are talking just that, you have just mentioned the word GMO.
Yes.
GMO in long form is what we call genetically modified.
Yes.
Seeds.
Yes. Yes.
Now, you are talking of improving cultural improvement of a seed.
Yes.
And now we are talking of GMO, which
Yes.
is the in thing currently in the country.
Yes.
Now, can you explain the difference between the two and
Yes.
maybe shed some light on
Yes.
it?
What happened when you talk about genetic engineering, it means constructing a gene. That's the engineering now. Constructing a new gene, which you are going to use for the purposes of the breeding. When you talk about natural cultural breeding, you are talking of the ordinary system, that is, you are talking of natural system, where you have the seed, maybe of the same species, and then you improve by looking at what is better from the other seed, and then you introduce through cultural breeding, that is cross-pollination, that's the one you do, which is different from genetic engineering. Genetic engineering is not breeding, it's actually constructing a new gene and insert it into a plant, which is a completely different thing. Genetically modified gene is a terminal gene, unlike the natural natural gene. Because when you talk about terminal gene, it means when you insert that gene in a plant, it is for a particular time. Maybe you are calling it for one season, and then you don't, from there it dies, it doesn't go into your plant. And the other thing which is very important is that gene which is constructed can mutate itself, can multiply, can go on mutating itself, like the way we had a problem with corona, and can spread to so many plants, other plants, unlike now the cultural breeding. With the natural cultural breeding, we have species. Say, I have about now 10 or 15, about 60 species in Amaranth. There are species which cannot cross the other. But with the terminal gene, it will affect every plant which it gets into, and terminate that gene which is in that plant, so that it can insert itself, it can go in its place. So it remove the gene which is there, and now replaces replaces the gene which is there. That's the difference now. The other one does not replace, it is still intact. But this one replaces the other gene because it's constructed. It's just like when you're talking about introducing a new system to it, like robots. When you have a robot, it is a person. It's not a person actually, but it can do that. It can work like a person. So actually, genetically engineered, genetically modified gene is actually a robot, not a plant. And what happens when you get the plant? It terminates the gene of the plant. So naturally, the plant dies, and it can terminate all the plant, all kinds of plant.
Now, let me understand this.
Yes.
When you say it's a terminal gene,
Yes.
what does that exactly mean? And number two, it is genetically modified. Does it mean it is modified from the soil or the seed, or it's something that is being done in a laboratory?
What happened with the terminal gene, with the genetically modified gene, it actually involves more than the plant. It involves the plant, it involves the human being, it involves the animals. So you can combine the three into a plant. I can take your ear and put it in a laboratory and develop a plant from there. I can take a dog and develop a plant from there. This is what means constructed gene. These genes are constructed, and that's why we have this problem of this gene, because finally it will terminate all the other genes. It can terminate any gene because it mutates, and when it mutates now, it means that it can go to any level. Nobody knows where it goes to. But when it comes to natural breeding, we have the mutations. A plant may not go beyond its other species.
So you mean it is something constructed inside the laboratory?
Yes.
Not, it is artificial.
It's artificial.
I want that
Yes.
point to come out.
The word should be artificial. Actually, the modified gene is artificial. We are creating now an artificial gene and insert it where we want, and for the reason we want it. One of the reasons we want it is we don't want to have a plant multiplying the seed. We just want the plant which can multiply a seed once. So when we terminate that gene, when that gene enters into that plant, it terminates the plant, is confined to only one season. After that season, it terminates the gene. It's terminated. And the problem also is, it can spread not only in controlled plants. Like in natural breeding, we control the plants. We say, okay, it's up to here. This is the way we control. This one is not controllable. It means it will spread through the weed, it will spread the water, and to go to other plants. And it can even go to the plants, to the trees, not only to the plants. It can even come to you as a person. So because it's a combination of a human being, of an animal, and also the plant.
Now, can you tell us the difference between a hybrid seed,
Yes.
or a grafted seed,
Yes.
and the genetically modified?
Yes. Now, the hybrid seed is improved method, is improved seed from the original seed. We normally say open pollinated can be improved to become hybrid, meaning you don't change the cells, you don't change the molecules, you don't change the tissues. It is the same seed, but you are saying, oh, fine, let me look for improving the yield, maybe increasing the flowers on the same seed, maybe increasing the seed. That's how it happens. But hybrid means level 1, level 2, level 3. When it goes to maybe level 4 or 5, then you cannot plant it again. That's what we say. When it is hybrid, you are improving a seed with a limitation of time, but not like genetically modified seed, because all the elements are there.
So you want to say, just as you have used the word terminal,
Yes.
GMO is meant to finish the original seed gene.
Yes, there's one time that will happen. We don't know when. Me and you don't know when. But one time will happen that it will terminate all the plants. Then we shall not have trees. We shall not have oxygen. Because trees give us oxygen. It can terminate that plant which is giving us oxygen. So you have to have it, because for it is a constructed gene. And if it spreads to these plants, it will go on terminating, including the natural plants, which gives us oxygen. So finally the country will not have any oxygen. And there we are, people die because there's no oxygen.
Try still to understand the same.
Yes,
This is an artificial gene.
yes,
So it means what we are talking about is purely an artificial seed, an artificial produce.
exactly.
So when we talk of chlorophyll, we talk of oxygen, we don't have that in
No,
our
it
gene.
affects all the processes of the seed. The seed, when we talk about seed, they are molecules. They are also cells. They are also tissues. They are all affected. We also talk about formation. What the seed does, it forms. Like now we have the amino acid profile, where protein is brought into small units, which are called amino acids. These amino acids are naturally made by the plants, but this one is a considered gene, which terminates the process, meaning that we do not have the protein that we require. We may have excessive protein than the protein that we really need in a crop. And another thing is that even if the carbohydrates is affected, even sugar is affected, it affects everything.
Now, we are talking of genetically modified.
Yes,
To our understanding
Yes.
is that the GMO is meant to increase food production.
yes,
Now, if you look at in a layman's language
yes,
or a layman's eye,
yes,
if you improve food or increase the volumes,
yes,
that is good for us.
yes.
So why the fear? If we are getting more food, what is wrong with that?
The scientists have been working on GMO, modified genetically organizations. Nobody has come up to give evidence that it can give more yield than the natural breeding hybrid or whatever you have. Because what happens in the plants, it depends on the feeding. How do you feed your plants? If it is the soil, how do you improve your soil so that you can increase your yield or you can increase the flowers? So this one does not mean that it may have better yield than the others. For me, I really say it may not have better yield than the other, because how many tons are we talking about? Which is the difference? And why? Does it mean that this seed has more weight? This seed has more flowers than the other one? Because even the other one can be improved to get the same thing.
Hey, you say once there was a time you mentioned something earlier
Yes,
that once you release this GMO,
yes.
you cannot control the seed,
Yes.
seed again. What
Yes.
do you mean by that?
What I meant is recalling the gene. There's something we call in the science, recalling the gene. An example of some plants here, which may have, you find a plant which has got two types of gene, and you may try to remove one by breeding. When it comes to GMO, you cannot recall the gene once it is spread out. It goes out and it starts mutating, so it goes out too for good. You may not be able to trace it. An example, I can be able to trace my plants, the emerald plant, which I have planted here. I can be able to trace it in this farm or another farm. I can look, this is the same variety which I had, but with the gene, with the GMO, you cannot trace that. It doesn't give you the ability to trace that. Another very important thing is that the equipment that tests toxicity of the plant that we already eat, we are now eating plants, and you know we have Kenya Bureau of Standard, which is testing the toxicity of our crop. We don't have equipment right now which can be able to test the toxicity of this plant. This is the problem now where we are, because the cells, the tissues, the molecules are all affected. So we are getting a new thing which may not work with the equipment that we already have. So it may be impossible to tell the toxicity of a GMO plant.
Now, still on the same line, I can see I'm still stuck in that point that you had said about terminal.
Yes.
The terminal.
Yes.
And I tend to get the feeling
Yes.
that once you invoke GMO maybe to a maize seed,
Yes.
it means that maize seed will never germinate again.
Yes.
Now, I just want to understand, is that good for us that I'm germinating a seed that will not germinate again, meaning it will keep me going back to the market to buy the seed for the next seed?
I wrote this book in 2015 and a chapter on GMO. I have a chapter on GMO. I never thought Kenya would have GMO when I was writing this book. And one of the things that made me interested in this, through my work, I have compared the natural breeding and genetically modified seed, and I have not found much difference, especially in terms of yield. What I have found is that in terms of the what we call viability of the seed, like now we have sugar in maize, we have fat in maize, we have seen a difference between the two. So you find that this maize or pumpkin, which is GMO, is not as sweet as the one which you really produced in a field. And therefore, if I get to your question again, your question was about
Sustainability.
sustainability. If you don't sustain your seed, if you are going to terminate the gene of the plant, it means that that is the end of that plant. And if that is the end of the plant, with the time factor, you will have no plants of that nature. So now we will terminate all the plants that we had before and now come up with new plants. And problem this new plant now is, if someone decides now to say, okay, fine, I don't sell you the seed again, where do you get the seed from? Because that seed is protected, it belongs to somebody, and that person is the owner of the seed. And we say, no, Kenya does not need this seed anymore. What do you eat? You have nothing. Because you terminated your plants, which you can plant, and now you have a new plant, which the owner says, no, I think I don't need this country to produce food anymore.
So it makes you dependent.
Makes you dependent, and only that, you are dependent, you are at the mercy of this person. It is how he wants you to do, is what he wants from you. You are at the mercy of this person, that he may decide what you want to decide. Because he can terminate, it can also, and I said it's combination of the human, of the animals, and of the plant. It can affect the three of them.
Now, let's go to the country now.
Yes.
We have the country like Kenya.
Yes.
There is a lot of land.
Yes.
And do you think it is advisable
Yes.
to start GMO farming?
Absolutely no. Because we have not exhausted. We have not exhausted our seed system. And I do not see why we are going to be controlled to be under somebody because of the seed. We have scientists in this country, many of them, who are seed scientists, who who are working. We have carried with so many scientists. We have other institutions, with even private ones, universities. Why don't we combine the efforts of these scientists to be able to come up with a production which can cater for this country? Why are we wasting your money? So what I think now, it is not a solution to us, it is a problem to us. And a problem that can affect even our own health. Because, as I say, this gene is not known what it can do in the future. It may be able to develop cancer. It may be able to damage all the plants' nutrition that we know. It may be able to destroy even our kidney and even the heart. You see, because of excessive protein, which does not get way out. You get the point? So now, purification that is done by a plant, when you plant a seed, when it is growing, there is a way it purifies itself to get the good plant that we today.
There is this point you had mentioned.
Yes.
Let's take, for instance, the seed, the maize seed.
Yes.
That the genetically modified seed does not have that heart.
Yes.
The seed.
Yes.
That it brings the nutrition. Still, I want you to come out very clearly about the risk of GMOs vis-a-vis now the plant not having enough nutrients to help you fight this.
Yes, our bodies are made dependent on the food that we eat. The food we eat is what we grow. An example is maize. Maize is very important for us. It has carbohydrates, it has fat, and it has many other things. It has even proteins and minerals, and it has even minerals. Everything will be affected by genetically modified. And I think what we are looking for is a short-term solution, the long-term solution. If you are looking for a long-term solution, then the GMO is not a long-term. It is a short-term that can have an effect over long-term. Because we may be saying, yes, let's have GMO because there's more use. But the question is, why are we not having the yield? Because scientists are not involved. If they are involved, they could improve the yield through the cultural breeding, improving the seed. Even if it is maize, they will produce more. We did have what we call extension services of the agriculture, Ministry of Agriculture, which does not exist at all in this country. The Ministry of Agriculture had extension officers who used to visit the farmers, advise the farmer the method of production, the method of preparing the land, the method of controlling soil conservation. They are no longer there. Countries like Tanzania, they have even farmer schools where farmers go to school, which we had in this country and was abolished. We had a system of extension officers which was abolished. So in the midst of agriculture, actually, we do nothing except collecting the salaries. Nobody is helping us to tell us what to plant, what not to plant. And that's why we are lacking food today, because we don't have the technology. The experts are not there. Research institutions cannot help, because they're just doing their small work there in research institutions. So what we need now is not the GMO. It is using the technology that we have from extension officers, from research institutions, from universities, combine them, and even retired scientists like us. There is so much work can be done. There is so much advice. I did work in Turkana, and it produced the best yield of green almonds, 10 tons from 1 acre, which is in history in my book. The book I've just told you. It has got something which is very important, unique. So we can develop a system of growing food in dry land, in semi-arid and arid areas, and even where we are. But because now the interest is on GMO, we are almost to GMO, which is actually somebody's property, which is bad. I don't see why we should finish open pollinated maize, like the one we had in Katumali. It was open pollinated maize, and people are very happy about it. Now it's no longer there. So, what we need to think about is not GMO. Think about how can we use the scientists that we have in this country, extension officers who are the trained agriculturalists. Then you also look at the materials that we have. Then you combine the efforts. You see, retired people working, they get together, they come to the seminars, and they come up with something that you can do.
Now, I understand GMO comes from the West.
Yes.
And some of the countries and the major countries in the West are avoiding
Yes.
using that one.
Yes.
What is your comment about that?
Nobody wants to be sick. And that's why those countries do not want to use GMO. I was educated in America, where GMO was being studied even when I was there. People never want to hear about it, because they know about it. And that's why it be brought in Africa, so that now, to cover our eyes with an excuse that we have got hunger in this country. We can finish hunger in this country if all resources are given to the scientists and extension officers. It can finish hunger because we can produce enough food, the food we want. We can even plant our own food. How much land do we have in Kenya, which is idle, even in the irrigation system? Look at what, no, don't even to Garana. Everywhere we have rivers, everywhere we have dams. Why can't we be able to use the technology, use our own people to be able to train other people? You see, I've been training now in production of grain animals. And we train people how to produce it. Why can't we train the other people how to produce maize and the rest? So what I think we need to do right now, the question is not whether we want a GMO or not. We don't need it. Let me tell you for sure. We don't need a GMO. What we need is now the government to mobilize resources of the scientists they have. The extension officers in the Ministry of Agriculture, the research institutions, the universities, the private people like us who can be able to assist in developing food. And finally, we have enough food for us and even export. I've been the best scientist in the world on this globe. One of the best scientists in the world. I've worked with the American organizations, institutions. I've worked with the Russian organizations. That's when I did work in Uganda. And at the beginning of the research, I did a research on what we call improving food through fermentation. That is trying to increase the nutrition. And I was the best scientist in the world, and I got an award from Netherlands government, $1,000 plus the books, as the best scientist, second best scientist in the world. So it's something I've worked on now for 35 years. I've been working on this code, and it has worked what else we can learn. Here, we also conduct training. If a group of people get together, we can train them. We have the seed for the animals, we can apply the seed, and other technical requirements that people may need, we can do that. I would like also to introduce my book, Introduction to Grain Animals, 3rd edition. It's a book I've authored, which has got a lot of chapters, about 24 chapters. And I've dealt with the production of grain animals. I've dealt with the grain animals being used as medicine, because there's a medicinal chapter. I've also written about nutrition. I've also written about the oil almonds oil, which is here, which is very good. And I'll give a small history of how we did a research in Kenya. There was a farmer in Kenya who was raising 500 pigs. And this farmer, who was raising pigs, used to buy the inflorescences and also the stems after he harvested the amaranth. And she raised the pigs, 500 pigs, using amaranth stuff, which increased the yield, lean meat from 34 kilos to 59 kilos. It also reduced fat from 13 kilos to half a kilo, meaning the farmer was happy when she was selling the pigs to Governor Choice. She was very happy with the cut. We have also dealt with the chicken. This book has all about that. Chicken feed. We have dealt with the chicken, raising chicken, and it's a powerhouse by itself. These books are available. I think if anybody wants a copy, we can. I think I better give my telephone number.
Sure.
Telephone number 0743 087 901. 0743, that's my number. 0787 901, Dr. Mwangi. You can get a copy of this book. It's only 1,500, and it has got 24 chapters. It has got growing the crop in Turkana and all over the countries and other countries in Africa. So it's a good book.